Welcome back to the Cisco NetAcad CCNA Switching, Routing and Wireless Essentials lecture series. If you haven't seen my previous lectures, I will leave a link in the description for the playlist. I would also like to recommend that you watch the Introduction to Networks lecture series before you go into this lecture series. Today, I will cover module number 5, which is EtherChannel. In this lecture, our primary objective is to learn how we can troubleshoot Ether channels on a switch links. We will cover EtherChannel Operation, how we configure Ether channels, and finally how we can verify and troubleshoot those Ether channels. EtherChannel Operation. Link aggregation. So there are scenarios in which more bandwidth or redundancy between devices is needed than that can be provided by a single link. Multiple links could be connected between devices to increase bandwidth. However, as we learned in our previous lectures, STP or spanning tree protocol enable layer 2 devices like Cisco switches will block redundant links to prevent switching loops. A link aggregation technology is needed that allow redundant links between devices that will not block by the spanning tree protocol. That technology is known as EtherChannel. So the EtherChannel is a link aggregation technology that groups multiple physical Ethernet links together into one single logical link. It is used to provide fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. So the primary purpose of an Ether channel, if you were asked that question in an exam, is to allow multiple physical Ethernet connections between devices and overcome the issue that STP may have posed with that as a result of having those multiple links. And therefore, the Ether channel method will allow you to create fault tolerance, load sharing, increased bandwidth, and redundancy between your intermediary devices. So EtherChannel technology make it possible to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication, because we are using more than one link between those switches. EtherChannel technology was developed by Cisco as a LAN switch-to-switch technique of grouping several fast Ethernet or gigabit Ethernet port into one logical channel. When an Ether channel is configured, the resulting virtual interface is called port channel. So if you have an Ether channel configured in here, for example, we have an Ether channel here and we have an Ether channel here. And the port, as a result of the combining these two links into one Ether channel, that will be called a port channel, because now it is an Ether channel, right? So that channel can be called port channel. The physical interfaces are bundled together into a port channel interface, which is shown in this diagram here. So what are the advantages of Ether channel? So Ether channel technology has many advantages, including the advantages listed here. And they include most configuration tasks can be done on Ether channel interface instead of on each individual port, ensuring configuration consistency throughout the links. So if you were to have additional links between your switches or routers, and you have those links independently, that you need to make sure the configuration is done exactly the same for each one of those links. But with Ether channel grouping, what's going to happen of grouping of those links, you can make those configuration on one single Ether channel, and that will impact all those physical channels that are associated with that Ether channel in one go. So that's one of the advantages. Ether channel relies on existing switch ports, so you don't need to have any specialized hardware in order to create those Ether channels, so that you don't need to upgrade the link to a faster or more expensive connections to increase more bandwidth because you are using these currently existing physical links, and you're just combining them together to increase the bandwidth instead of buying or upgrading your physical network. It allows load balancing to take place between links that are part of the same ether channel. So if you have a bunch of links, as I mentioned, combined in these ether channels, that will allow you to create the load balancing within those links. An ether channel creates an aggregation that is seen as one logical link. So when several ether channel bundles exist between two switches, STP may block one of the bundles to prevent switching looping. Looping effect. So we learned about that on our previous lecture, how the STP prevents looping of those messages. When STP blocks one of the redundant links, it blocks the entire ether channel. This blocks all ports belonging to that ether channel link. Where there is only one ether channel link, all physical links in that ether channel are active because STP sees only one logical link. So in other words, that imagine you have a network with multiple connections that doesn't have the ether channel created. What's going to happen is that the STP will block all the links except one physical link to prevent looping effect, right? So that means you basically got rid of your redundant link because you now only have one physical link. But by creating ether channels, by combining some of those links into one ether channel and the other links into a second ether channel or third ether channel, what's going to happen is that the STP will block that ether channel itself and allow one of the ether channel to be active and without having a blocking there. So what's going to happen is that STP may block the redundant ether channels, but it will leave the primary ether channel as in on position. So what's going to happen is that even though you only have one ether channel and the STP have blocked the rest of the ether channels, because that one ether channel have multiple physical links, you still have the redundancy built into it. Your network still have the redundancy, even though the STP is blocking the other ether channels, because the ether channels are aggregates of multiple channels, multiple connections, right? So that's why. So ether channel provides redundancy because overall link is seen as one logical connection. So that's what they are describing right here, but I just explained here. So the ether channel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. So when the STP is looking at the topology, it sees these ether channels. So if one of the links within the ether channel get disconnected or goes down, the STP doesn't have any impact on the STP, because reason for that is the ether channel is still up because the other links within the ether channel is still up. So the loss of one physical link within that channel, it doesn't create any changes in STP topology and how the STP looking at it. So I wish I can draw on this so I can give you a better idea. So let's say you have a bunch of channel links like that, and you have a bunch of links like that, and this is one ether channel and this one ether channel, right? So the STP look this entire channel as one channel and this entire channel as another channel. So it sees two channels, so it's going to block one of them. So this is blocked now, right? So this ether channel is now active. So it is actually active because the STP is doing its work, right? But however, if one of the links here, so we have multiple links like that. So if one of the links here goes down, the STP only sees this as one single ether channel. It doesn't care that one of the links went down within that ether channel, because STP does not change the topology here, because this ether channel is still the same ether channel even though one of the physical links have gone down. As opposed to having all of these links separate, if you have all those links separate like that, what's going to happen is that if one of these links goes down, the STP will now unblock all of these, one of these, in order to make sure that the communication still remains. So basically STP will be blocking all of these links except the link that is communicating, right? So when one goes down, it's going to change the topology. But in EtherChannel, it doesn't matter because the link is within that channel. So the channel is like, having all the stuff inside, and the STP see this one channel as a single unit. So that's what this is trying to describe here. EtherChannel has certain implication restrictions, however, that includes the interface types that cannot be mixed. For example, fast Ethernet and gigabit Ethernet cannot be mixed within a single EtherChannel. So if you have a Cisco switch or any other switch, IBM or HP switches, for example, with both fast Ethernet and gigabit ports, you only can combine gigabit ports together for your EtherChannel and the fast Ethernet ports together for your EtherChannel. You can't mix them up. Currently, each EtherChannel can consist of up to 8 compatibly configured Ethernet ports. EtherChannel provides full duplex bandwidth up to 800 megabyte per second on fast Ethernet channel, or up to 8 gigabyte per second gigabit EtherChannel between one switch and another switch host. The Cisco Catalyst 2960 layer 2 switch currently support up to 6 EtherChannels. The individual EtherChannel group member port configuration must be consistent on both devices. If the physical ports of one side are configured as trunk, the physical ports of the other side must also be configured as trunks within the same native VLAN. That is very important. So the individual Ether group member port configuration must be consistent. Otherwise, it will not be able to communicate. So you need to make sure the physical port of one side are configured as trunk. If it is considered as trunk, the other side should also be configured as trunk within the same native VLAN. So the consistency matters as anything with network engineering, like we have learned in previous lectures. Both sides has to agree upon what type of communication method and configuration will be using for that communication purposes. Otherwise, the communication won't happen. Additionally, all ports in each EtherChannel link must be configured as layer 2 ports. So if it is not configured as layer 2 ports, it will not work. Each EtherChannel has a logical port channel interface. A configuration applied to the port channel interfaces affects all physical interfaces that are assigned to that interface. So that is also an important concept that you should know. Auto negotiation protocols. So EtherChannel can be formed through negotiation using one of 2 protocols. One is the port aggregation protocol, also known as PAGP, or the other option is the link aggregation protocol, also known as LACP. These protocols allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. So that's a very key feature that auto negotiation protocols allow us. And I will go over what is PAGP and such in next few slides. But you should know these 2 protocols are being used but in the auto negotiation process by EtherChannels. Note, it is also possible to configure a static or unconditional EtherChannels without PAGP or LACP as well. So let's look at the PAGP operation. PAGP, also pronounced as PAGP, is a Cisco proprietary protocol that aids in the automatic creation of EtherChannel links. When an EtherChannel link is configured using PAGP, the PAGP packets are sent between EtherChannel capable ports to negotiate the forming of a channel. When PAGP identifies match Ethernet links it groups the links into an ether channel. So the PACP messages, the packets, will identify what Ethernet links going to be matched for a particular associated ether channel, and then that will be used to link those groups into an ether channel. The ether channel is then added to the spanning tree as a single port. Remember, in the previous slide I mentioned one of the key features of ether channel is that when you combine those links together into ether channel, the STP, the spanning tree protocol, only see that channel as a one single link or one single channel, even though there are multiple physical links within the ether channel. When enabled, the PACP also manages the ether channel. PACP packets are sent every 30 seconds, and PACP checks for configuration consistency and manages links, additions, and failures between two switches. It ensures that when an ether channel is created, all ports have the same type of configuration. So PACP also making sure that the consistency between devices that are being connected through these ether channels. Please note, in ether channel it is mandatory that all ports have the same speed, same duplex setting, and VLAN information. Any port modification after the creation of the channel also changes all the channel ports. So remember that. We need to be consistent with how we are configuring the ports when you are trying to configure ether channels, because otherwise the system will not work. So if we look into PACP a little bit in detail, PACP creates the ether channel link by detecting the configuration of each side and ensuring that the links are compatible so that the ether channel link can be enabled when needed. And if you look at the PACP modes, they include the on mode, PACP desirable mode, and PACP auto mode. So the on is a mode that forces the interface to channel without PACP. Interfaces configured in the on mode do not exchange PACP packets. So this is an important concept some people get confused about, because they look at like, oh wow, the PACP mode is on, so it must be sending PACP packets. But no, it's not. Basically, if the mode for PACP is set as on, that basically means is the mode do not exchange PACP packets. This is a question some people may get confused on exams, or may remember. You should remember this, but this key piece of information for your exams and quizzes, because I got confused on exams on Cisco CCNA exams as well, because in our mind automatically when you think about on, you will think, oh yeah, the PACP is on, it must be sending PACP packet, but actually the on mode will not send PACP packets. Then the next one is PACP desirable mode. This PACP mode places an interface in an active negotiation state in which the interface initiates negotiations with other interfaces by sending PACP packets. So that's the PACP desirable. So it places the interface in an active negotiation mode, and the interface will send out those PACP packets as a result of PACP desirable. The PACP auto, the next mode, that mode places an interface in a passive negotiation state in which the interface responds to PACP packets that is received but does not initiate PACP negotiation. So for your exams and quizzes and for your understanding of how PACP works, you should be able to differentiate between those two and understand the concept behind on, desirable, and auto. So especially desirable is where that the PACP packets are actively sent out to start to try to get the negotiation going, and PACP auto does not initiate that PACP negotiation process, but however it will respond to any packets that receive through the PAC-P process. So you should understand the differences. So again, the on mode will not send any PAC-P packets. The desirable mode is in an active negotiation state and it will send out PAC-P packets. The PAC-P auto mode is in passive negotiation mode as opposed to active negotiation in desirable. So in desirable, it is active negotiation. In auto mode, it is passive negotiation state. And the interfaces will respond to PAC-P packets that it receives but does not initiate the negotiation. In here, the desirable, it does initiate the negotiation. So you should know these three differences, and you should be able to identify them on an exam or a lab exam when your instructor asks you questions about PAC-P. The modes must be compatible on each side. If one side is configured to be in auto mode, it is placed in a passive state, waiting for the other side to initiate the EtherChannel negotiation. If the other side is also set to auto, the negotiation never starts and the EtherChannel does not form. That is another key piece of information you should remember. People misunderstand what this on auto desirable means because of the word association in English language, right? We think, oh, it's going to do everything auto if both sides are set to auto. No, it doesn't. If one side is set to auto, the negotiation never starts and EtherChannel does not form, in that case, right? Because the other side is also auto. If all modes are disabled by using the no command, or if the mode is configured, then the EtherChannel is disabled. The on mode manually places the interface in an EtherChannel without any negotiation. It works only if the other side is also set to on. So if the both sides are set to on, it will work. If the other side is set to negotiate parameters through PAC-P, no EtherChannel will form. If one side is on, the other one is negotiate, it doesn't work because the other side, because the side that is set on mode does not negotiate. So the on side doesn't negotiate, it can work. No negotiation between the two switches means that there is no checking to make sure that all links in the EtherChannel are terminating on the other side, or that there is PAC-P compatibility on the other switch. So this is a very key piece of slide that you should remember for your exams. And I will show you a table on my next on my next slide that has some overall view, configuration of this concept. But remember, the modes must be compatible on each side. If one side is configured in auto and it places in the passive state and waiting for the other side to initiate the EtherChannel negotiation, if the other side is also set to auto, the negotiation never starts and does not form. So those key concepts will show up on your CCNA and CCNP exams, and you should be able to understand those concepts and apply those concepts, especially on lab exams, especially it's been conducted by your instructor. Your instructor may ask you during the lab exam these questions, depending on who's conducting the exams and what academic institution you have registered this course with. So be careful that you don't get confused between on, disable, and auto. So as I mentioned, this is an example table that give you an idea about how PAC-P mode settings works. So we have two switches here with an EtherChannel, and we have the PAC-P enabled. So we have switch 1 and switch 2, and they have two links. So this table shows various combination of PAC-P modes on switch 1 and switch 2 and the resulting channel establishment outcome. So we have switch 1 with on mode on PAC-P on, and the switch port in PAC-P on, and the channel will establish because they are both on, right? So they are compatible. They will establish. if the switch 1 is on, the other side is set to disable auto, no, it will not create the channel establishment. If we have the switch 1 in disable and the switch 2 in disable, yes, it will create the channel. And both one side is disable, the other side is auto, yeah, it will create it. Once same here, it's just switched around, so one side is disable, one side is auto, it will. But if both sides are auto, it will not create it. So if both sides are on, yes, but if both sides are auto, no, it does not create it. So that's what you need to get out of this slide. So this is a very important concept. It does show up on your exam. I guarantee you there will be quiz questions and exam questions and even lab exam questions associated with this, especially on CCNA exams, but sometimes also shows up on CCNP exams. Now let's look at LACP operation. LACP is a part of IEEE specification 802.3 AD that allows several physical ports to be bundled to form a single logical channel. Remember, PAG-P is a Cisco proprietary, even though it is used by other manufacturers, but LACP is IEEE international standard, which is 802.3 AD standard. LACP allows a switch to negotiate an automatic bundle by sending LACP packets to the other switch. It performs a function similar to PAG-P with Cisco EtherChannel. Because LACP is an IEEE standard, it can be used to facilitate EtherChannel in multi-vendor environments. So remember, this is a question that do show up. PAG-P is a Cisco proprietary, so if you have a multi-vendor environment, LACP may be the best option for EtherChannel. On Cisco devices, both protocols are supported, so the Cisco devices can handle both LACP and PAG-P, and most other vendors almost guaranteed anytime they support EtherChannels, their devices from those vendors support LACP. So if you are mixing those other vendors' devices and equipment with your Cisco devices, I would also recommend going with LACP. LACP provides the same negotiation benefits as PAG-P. LACP helps create EtherChannel link by detecting the configuration of each side by making sure that they are compatible so that the EtherChannel link can be enabled when needed. So the modes for LACP are similar to that of the PAG-P. So we have on mode, LACP active mode, and LACP passive mode. So the on mode forces the interface channel without LACP. Interfaces configured in the on mode do not exchange LACP packets. Remember, even in PAG-P, when it is on mode in PAG-P, it doesn't exchange the PAG-P packets, right? Same thing apply in LACP. If it is on mode, it doesn't exchange the LACP packets because the mode interface is set without the LACP in the on mode. The LACP active mode allow the port to place in an active negotiation state, similar to the previous one we discussed with PAG-P. And in this state, the port initiates negotiations with other ports by sending LACP packets. The LACP passive mode, similar to the previous one, in this case, places the port in a passive negotiation state, and in this state, the port responds to the LACP packet that it received but does not initiate the LACP packet negotiation. So if you look at the PAG-P, down here we just discussed, so we have on, PAG-P desirable, and PAG-P auto, right? In LACP we have on, LACP active, and LACP passive. So even though the terminology is different because of the different technologies, one is LACP, one is PAG-P, if you look at the description of what these modes are doing, for example, LACP active mode have a port, have the port on active negotiation state and it is actively seeking to negotiate, right? But if you go to PAG-P, and in here we see the PAG-P desirable mode does the same thing. It is actively negotiating, the establishment of those ether channels. So the PAG-P desirable and PAG-P auto is equivalent to LACP active and LACP passive, and the on is same in both. So that's an easy concept to understand. Just remember those are two different way of doing those negotiation, and the LACP is the IEEE standard. And if you have a mixture of Cisco devices and other vendor devices, we would usually go with LACP, as PAG-P is Cisco proprietary. But I want to give you a caution about here, because there may be some third-party vendors that using Cisco proprietary PAG-P within their devices too with proper licensing. So these slices are created in 2016, so there may be some agreement with Cisco and other third-party vendors that does have the PAG-P capability, even though the hardware is not manufactured by Cisco. So that's something to keep in mind when you go through these lectures. What's important here, that we learn the concepts and methodologies and engineering and technological systems goes into creating ether channels, not so much the vendor specific items, other than to know which are vendor specific and which are not, right? So what we are trying to do here is learn network engineering, not learn how Cisco and IBM works, right? So that's an important thing you should remember. So in here, just like PAG-P, in LACP, we have an example with the same switches, but this time the switch 1 and switch 2 is configured with LACP with these two ether channels, with these two links with the one single ether channel. So remember, these two links are part of one single ether channel, and we have used LACP mode on different modes on switch 1 and switch 2. So let's see what happens. So when you have both switches set to LACP on, it will establish the connection. It will create that ether channel. So when you have one side on, the other one is active or passive, it will not create that ether channel. If you have both sides active, it will create the ether channel. If you have one side active, the other side passive, it will create the ether channel. If you have one side passive, the other side active, it will create the ether channel. But if both sides are passive, it will not create the ether channel. So remember that in LACP, if both sides are on, it will establish the ether channel. If both sides are passive, it will not establish the ether channel. And you can pause this video here again, just like you can pause it on the PAG-P example with the table, to understand how those different modes may have an impact on the establishment of that channel. Now we will look at how you can configure ether channels. So let's look at the guidelines for configuring ether channels. So there are some guidelines and restrictions that are useful when you are creating ether channels. So one thing you should look at is the ether channel support. So all Ethernet interfaces must support ether channel with no requirement that interfaces must be physically contiguous. We also need to look at the speed and the duplex, because remember, all those ports and interfaces should have the same speed and same duplex configuration, right? So you need to make sure that you configure all interfaces in an ether channel to operate at the same speed and in the same duplex mode. Otherwise, it will not be able to establish an ether channel. VLAN match. So all interfaces in the ether channel bundle must be assigned to the same VLAN or be configured as trunk. So the figure, I will show you the figure in the next slide. Then the range of VLANs. So an ether channel supports the same allowed range of VLANs on all interfaces in a trunking ether channel. If the allowed range of VLAN is not the same, the interfaces do not form an ether channel, even when they are set to auto or disable mode. So if you have a VLAN match, but you have a additional VLANs range that are not same on those, on those ports, what's going to happen, those interfaces, what's going to happen is that the negotiation process doesn't work, and therefore the channel will not be created. So the figure that I was referring to is or in the previous slide is this figure. So the figure shows a configuration that would allow an ether channel to form between switch 1 and switch 2, right? We have S1 and S2. This is S1, this is S2. So if these settings must be changed, configure them in port channel interface configuration mode. Any configuration that is applied to the port channel interface also affect the individual interfaces. So remember that. Any changes that you would make in the configuration associated with the port channel interface also will impact individual interfaces. Remember what is a port channel interface, right? Port channel interface is when you combine multiple interfaces together to make an ether channel. That ether channel interface is known as the port channel interface. So that's what it's saying here, because all those other physical channels are now combined into that one single ether channel. That one port channel within that, or that port channel representing that ether channel, will have a direct impact on the channels in that ether channel, right? So that's why when you change a configuration on that port channel, those individual interfaces associated with that ether channel, which is part of that port channel, gonna have the same changes impacted by that. So whatever changes you make on that port channel have an impact on those individual interfaces. Therefore, making those configuration changes to an interface that is part of the ether channel link may cause interface compatibility issues. So instead of making changes into one single, in one interface, when you have an ether channel, you're gonna make changes on that port channel. So the port channel can be configured in access mode, trunk mode, which is the most common mode, the trunk mode, or on a routed mode port. So those are the three options that you have for configuring port channels. So in here we have a port configuration on the switch 1, where we already have a ether channel formed with the switch 2, and we have the speed set to gigabit, 1 gigabyte per second. And if you look at the switch 2 speed, it also the 1 gigabyte per second. We have duplex mode at full, and we have duplex mode here full as well. So if they are compatible, yeah, they are. And then we have the same VLAN association here and same VLAN association here, in this case 10 in this example, and therefore the ether channel will establish and it will work properly because both sides are the same. So when you're configuring ether channel with LACP, it requires the following steps. So the very first step we're going to do is to specify the interfaces that compose the ether channel group using interface range command in the global configuration mode. The range keyword allows you to select several interfaces and configure them all together. So on Cisco switches, if you enter interface range command, and then that command will allow you to add more than one, configure more than one interface at a time. So right here, you can see that on the bottom, interface range, fast Ethernet, they are using fast Ethernet 01 and 02. That's why 01-2 here. And again, when you get going with your labs, I will show you on my lab demonstrations. You don't need to even enter this entire command. You can go int range FE, for example. It's a short form. That would work as well. It's just the same thing. But what key here is that the interface range command is used to configure multiple interfaces in a one go. So the next step is, after you enter interface range command and you enter the the interfaces that you're going to be configuring, is to create the port channel interface with the channel group command with the identifier, and you're going to set that mode to whatever the mode that you like. In this case, we're going to put it into active mode. And the identifier specify a channel group number. So this is a group number we're going to use. the mode active keywords identify this as an LACP ether channel configuration. So we're going to do channel-group and we're going to give it a number. In this case, it's number 1 we're going to use, and we're going to put the mode into active. And the next step we're going to do is to change the layer 2 settings on the port channel interface and enter port channel interface configuration mode using the interface port channel command. So you can see that is being used, interface port channel, and followed by the interface identifier. So in this example, the identifier going to be like 1, 2, 3, like a numeric number. So in this example, S1 is configured with the LACP ether channel. The port channel is configured as a trunk interface with the allowed VLAN specified. So in here we have gone through the group configuration to the group 1 mode active, and then we have the message back from your Cisco switch in here saying, hey, we are creating the port channel interface port channel 1. That's for you to verify that, hey, that port channel interface has been created. So you're going to exit out of that. Now you're going to go back into, not to the interface range here, but to the interface of port channel that we just created up here using those 2 interfaces. So in this case, we're going to go into interface port channel 1 configuration. And inside there, we're going to give switch port mode trunk and switch port trunk allowed VLANs and whatever the VLANs you're going to allow. And those 2 commands going to configure that ether channel. So there is a packet tracer file called configure ether channels. I believe I found those packet tracer files, so I will post it to my website, so you can go ahead and download them and you can do those labs as you go through this lecture. If you have access to these packet tracer files through your academic institution or Cisco NetAcad, you can go ahead and download from there as well. I would recommend that you do these labs as you go through this lecture, as opposed to just completely go through the lecture and going back and doing them, because this will give you a better idea about what we just covered. Verify and troubleshoot ether channel. So finally, we're going to discuss how we can verify and troubleshoot our ether channels. So how do you verify and the ether channel that you have created? So as always, when you configure any device in your network, you must verify your configurations. If there are problems, you will also need to be able to troubleshoot and fix them. There are a number of commands to verify ether channel configuration, just like any other configurations that we can verify with Cisco switches and routers. So with ether channels, the show interfaces port channel command displays the general status of the port channel interface. The show ether channel summary command displays 1 line of information per port channel. The show Ethernet port channel command displays information about a specific port channel interface. The show interfaces ether channel command can provide information about the role of the physical number interface of ether channel. So I know, just again, going through these kind of lectures, sometimes it's going to be very confusing to just look at the command and read them and understand them. As a network technician or network engineering student, you should know what these commands do before you go into the lab. Don't just randomly enter commands, because you are not going to learn much from it. So that's why we are going through these lectures first. So what I'm going to do, I will do a live lab demonstration, and I will put a video clip on my YouTube channel setting up ether channel, and I'm running through these commands, so you will have a better understanding of how these commands work in a lab environment. But for now, just understand what these commands do and how they help us verify our ether channel. So what are the common issues with ether channel configurations? All interfaces within an ether channel must have the same configuration of speed and duplex mode, native and allowed VLANs on trunks, and access VLAN on access ports. Remember, I have been repeating this on my previous slide over and over again. Everything has to be same between your devices that are trying to establish these ether channels, otherwise they won't be working. So ensure these configurations will significantly reduce network problems related to EtherChannel. Ensuring these configuration that are correct will be the first step to troubleshooting anything. So the common EtherChannel issues include assigned ports in EtherChannel are not part of the same VLAN or not configured as trunks. Ports with different native VLANs cannot form an EtherChannel. As a result, that's going to create a problem with your channel. Trunking was not configured on some of the ports that make up the EtherChannel, but not all of them. So that means you have created some trunking, but not all of the items within that EtherChannel doesn't have the trunking configured. It is not recommended that you configure trunking mode on individual ports. Remember, that make up the EtherChannel. I have mentioned that before. So when you're configuring a trunk on an EtherChannel, verify the trunking mode on EtherChannel itself as well. If the allowed range of VLANs is not the same, the port do not form an EtherChannel even when PAGP is set to auto or desirable. Remember that. Allowed VLAN range has to be the same as well. So make sure that it is same. The dynamic negotiation options for PAGP and LACP are not compatibly configured on both ends of the EtherChannel will also result in not forming your EtherChannel. So for the dynamic negotiation option, remember those two tables that I had on my previous slides. So make sure you go through them and understand what each of these configuration mean for your EtherChannel. That will help you troubleshoot your EtherChannel issues associated with the configuration modes. In this figure, the interface F01 and F02 on switches S1 and S2 are connected with an EtherChannel. However, the EtherChannel is not operational. So this is an example troubleshooting question that the Cisco came up with. So remember this slide, because next slide we don't have this diagram, but we will be looking at how we can troubleshoot this scenario. So we have a switch here and we have a switch here, and they are connected with two links. We are trying to create this EtherChannel between those links. But however, it is not operational now. So now we're going to go ahead and troubleshoot it. So the step 1, view the EtherChannel summary information. The output of the show EtherChannel summary command indicates that the EtherChannel is down. So if you go to the switch 1 of the previous diagram and you enter the command show EtherChannel summary, it shows that the EtherChannel is not formed and it is currently down, and it's showing right here as the channels are down. Step 2, view port channel configuration. In the show run pipe begin interface port channel output, will give you a more detailed output that indicates there are incompatible PAGP modes configured on switch S1 and S2. So you enter show pipe begin interface port channel here, and then on switch 2 you're going to run the same command and then you will get that information about PAGP modes. And you can see the PAGP mode are not configured properly, because you see here that we have here on the switch 2, we have the mode desirable, the group 1 mode desirable in the PAGP, and here we have the PAGP mode as on. And if you remember from previous slides, if you have on one side and desirable on the other side, that will not establish a EtherChannel using PAGP modes, because the PAGP modes that we have created on switch 1 is incompatible with what we have on switch 2, so they can't actually create the EtherChannel. So now we know the problem. In step 3, what we're going to do is we're going to correct the misconfiguration now. So to correct the issue, the PAGP mode on the EtherChannel is changed to desirable. So note that the EtherChannel and the STP must be interoperate. For this reason, the order in which the EtherChannel related commands are entered is important, which is why you see the interface port 1, which is why you see the interface port channel 1 removed and then re-added with the channel group command, as opposed to directly being changed. If one tries to change the configuration directly, STP errors cause the associated ports to go into blocking or established state. So you can actually see, in order to fix this problem, you can't just go ahead and just quickly change that mode to desirable. What you need to do, actually, you need to remove that port channel first. So you're going to go no interface port channel 1, and then you're going to enter the interface range again. You're going to go through the configuration steps again, and this time you're going to set that mode to desirable on the S1 switch, because if you go to the previous slide, during our troubleshoot process, you saw that the switch 2 have the mode set up as desirable. So if you put the switch 1 also into desirable, that will establish the ether channel. But however, because these commands must be entered in proper order, you have to first remove the interface port channel 1 and re-establish that, re-enter that command interface range as well as the port channel 1, and then this time you're going to give the disabled mode. So that is a key important piece of information that you should understand. EtherChannel and STP must interoperate. Therefore, the order in which the EtherChannel related commands are entered is important, which is why you have to remove the interface port channel 1 before you change the mode and re-establish that port channel. Right? So the no shutdown command will re-establish that port channel, because otherwise what's going to happen is STP error is going to cause associated port into blocking mode, and it's going to be error disabled state. So that's a key piece of information when you're doing labs. So finally, now we have corrected the issue. You can verify the ether channel is operational by using the show ether channel summary command, and the show ether channel summary command on switch 1 now shows that the ether channel is established right here, and it is currently working and everything is good to go. So that is a really good example of troubleshooting. So there is a packet tracer file called Troubleshoot Ether Channel, and it will go through what we have covered right now. If you have access to these packet tracer files through your academic institution or through your Cisco NetAcad, please go ahead, download them and do them. And if you do not have access to these packet tracer files, I will make sure to get a copy of that and post it onto my website so you can do them at home. That would bring us to the end of this lecture, and we will look at what we have learned in this module, as well as few packet tracer files that you should be working on. So again, there is a packet tracer file called implement ether channel that would cover everything we covered in this lecture. I will try to find a copy of that and post to my website so that you can go ahead and do them. If not, if you have a copy of that, please do them so that you will understand everything we covered in this lecture. There's another packet tracer file which is a lab file called implement ether channel. Again, that will go through the steps of implementing an ether channel. If you have access to this file, go ahead and do them. If not, I will try to find a copy and post to my website so you can do these labs as you go through these lectures. So finally, let's look at a summary of what we have learned. We learned to increase bandwidth or redundancy, multiple links could be connected between devices. However, because of the STP, spanning tree protocol, that will block redundant links, hence preventing switching loops. But however, that will also means that you're gonna lose that redundancy. EtherChannel is a link aggregation technology that allows redundant links between devices that will not be blocked by STP. Because remember, STP gonna see the ether channel, all the links in a group as a one single channel, so it's not gonna block the links within that ether. Ether channel groups multiple physical Ethernet links together into one single logical link. So the primary purpose of an ether channel like the primary function of the Ether channel actually is to group multiple physical Ethernet links together into one single logical link. It provides fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. When an Ether channel is configured, the resulting virtual interface is called a port channel. Remember that too, because that do show up on your exams. So when the Ether channel is configured, the resulting virtual interface which the STP is seeing is considered as a port channel. Ether channels can be formed through negotiation using one of two protocols, PAGP or LACP. These protocols allow ports within similar characteristics to form a channel through dynamic negotiation with adjoining switches. So remember, the purpose of PAGP or LACP is to allow the ports with similar characteristics to form channel through dynamic negotiation with adjoining switches. When an Ether channel link is configured using Cisco proprietary PAGP, the PAGP packets are sent between Ether channel capable ports to negotiate the forming of the channel. Modes for PAGP includes on, PAGP desirable, and PAGP auto. LACP performs a function similar to PAGP, which is a Cisco proprietary, right? So PAGP is Cisco proprietary, but LACP perform a similar function, but it is IEEE standard and it can use to facilitate Ether channels in multi-vendor environments. And the modes for LACP includes on, LACP active, and LACP passive. As I mentioned before in the slides, in this lecture, the PAGP on, desirable, and auto is similar to LACP on, active, and passive. So you can kind of look at PAGP desirable similar to LACP active, PAGP auto similar to LACP passive, even though they are different and their behaviors are slightly different from each other. You should know what are the differences and how they are also related to each other. We also learned the following guidelines and restrictions are useful for configuring Ether channel. All Ethernet interfaces on all modes must support Ether channel with no requirement that interfaces by physically contiguous or the same module. So remember that all Ethernet interfaces on all modules must support Ether channel with no requirement that interfaces be physically contiguous or on the same module. Configure all interfaces in an Ether channel to operate at the same speed and in same duplex mode. So if the duplex modes or speeds are not matching, the Ether channel will not be established between devices. All interfaces in the Ether channel bundle must be assigned the same VLAN or be configured as a trunk. And Ether channel supports the same allowed range of VLANs on the interfaces in a trunking Ether channel. And if a trunking Ether channel you are trying to establish have a different VLAN range, it will not work either. And when you are configuring Ether channels with LACP, that requires 3 steps. The very first step is to specify the interfaces that compose the Ether channel group using the interface range command in the global configuration mode. And the step 2 is to create the port channel interface with the channel dash group. When you're going to give identifier 1, 2, 3, or like channel group 1, for example, with the mode active command in the interface range configuration mode. To change layer 2 settings on the port channel interface, we're going to enter the port channel interface configuration using the interface port channel command in the step 3 of this process. And then you're gonna give the identifier number afterwards. So you're gonna be interface port dash channel, and you're gonna go 1, 2, 3, whatever the channel command. So those are 3 steps that you need to take to create LACP or Ether channel. So Ether channel with LACP. We learned there are a number of commands that we can use to verify EtherChannel, especially when you are troubleshooting and making sure that your configuration is properly created. And they include show interfaces port channel, show EtherChannel summary, show EtherChannel port channel, and show interfaces channel. EtherChannel. So the common EtherChannel issues we covered include the assigned ports in the EtherChannel are not part of the same VLAN or not configured as trunk. Ports with different native VLANs cannot form EtherChannel, and hence resulting in not establishing your EtherChannel. Trunking was configured on some of the ports, but not all. That will also result in not establishing your EtherChannel. If the allowed range of VLANs are not the same, that will also result in a problem, and that will not perform. That will not form, the EtherChannel, even when the PAC-P is set to auto disable. Remember that. And we also learned that the dynamic negotiation option for PAC-P and LACP are not compatibly configured on both ends, will also result in not forming the EtherChannel. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions or concerns regarding anything we covered, please feel free to reach out to me either through leaving a comment on one of my videos or through my website. Until next time, good luck with your exams and have a nice day.